Hey everybody, welcome to topic number 11. In this lecture video, let's take a look at what we so-called functions and graphs. So before I talk about function and graph, let's take a look at what we something called the set notation and interval notation. All right, a set notation, the word set is basically like a basket. So a solution set is basically like a basket full of solutions. So a solution set is basically a set of all solutions. It's basically the way how we will write our answers. So for example, x greater than 8, right? X greater than 8 means we will be looking for all the numbers that are greater than 8. Therefore, there's a lot of answers, okay? So the solution set or the set builder notation will be written as a brace. Brace is the word set. It's a set of all x's. The slash means the word such that. It's a set of all x's such that x are greater than 8. Okay, so that's the way, that's the formal way how we can actually write our solutions. Okay, for something like a x greater than 8, because x greater than 8 technically has infinite number of solutions. We talk about set notations in a previous video where we solving for quadratic equation. So normally the simplest way is basically just write our answer inside the brace. So for example, if I want to write x equal to 8 in the set notation, graphically speaking, let's say 0 is here on the number line, 8 is right here. So when my answer is 8 on the graphical approach, we'll just put a dot right there where 8 is. So when we write our answer in a set notation for an answer, just a single answer like x equal to 8, we would just simply put 8 inside this brace. Okay, so that would be a set of all. So basically, this is how we would describe our answer. It's only one answer, so I just write 8. I don't have to write x. Set of all x is such that x equal to 8. You know, this is a shorthand way to just write our answer inside the set notation. Interval notation. Interval notation is really used for the following things. It's used for solution within certain interval using inequality. So whenever we use inequality, we will use interval notation. When we're describing domain and range of a function, which I will define these two words in a minute, when we use domain and range of function, we will use interval notation. So generally speaking, we always read the inequality from the variable as we done before when we review graphing the inequality. So if you read x greater than 8 this way, and if I will write it this way, x greater than 8, if you read from the variable, you are saying the same thing. So we will write the interval notation from left to the right when we read the number line. Okay. So why do we always read number line from left to the right? When we read number line, we always read from left to right because we are reading from small number to a large number. So when we drew whatever we need to draw on the number line, when we read it, we always read from small number on the left all the way to the big number on the right. Okay, so in high school, you probably use open circle and solid circle. Okay, so that doesn't apply here. In order to use interval notation, we will use brackets and parentheses. Bracket is for inequality involving with equal to. Parentheses is for inequality without the equal to, less than, greater than, and we will also use parentheses for my infinity sign and the negative infinity sign. So if I want to express x greater than 8 as interval notation, so let's draw this on the number line first. X greater than 8, so 0 is here, 8 is here, for example. X greater than 8 is referring to looking for all the numbers that are bigger than 8. Numbers bigger than 8 will be to the right-hand side of 8. So how many answer is to the right of 8? It should be what? Infinite number of answers are bigger than 8. Since the inequality does not have an equal to, I will use a parenthesis. So we read from small answer to the large number, right? So when we write the interval notation, we will say 8, but not including 8, that's why the parenthesis is for. The parenthesis is basically telling the reader 8 is not part of the answer, but 8.1, 8.11 will be part of the answer. So my answers are 8, comma is the word 2. My answers are from 8 using parenthesis all the way to infinity. Since we cannot capture infinity, so we will always use parenthesis for infinity sign. All right. If you read from the variable, the next example says x less than equal to 8, right? Number that are smaller than or equal to 8. So let's say 0 is here, 8 is here. Number smaller than 8 got to be to the left side of 8. How left does my answer go to? It got to be, if I keep going, it got to go to negative infinity. All right, so because I have an equal to, that means I will use bracket this time, which implies 8 is part of my answer. Parenthesis means that 8, previous example, was not part of my answer. So when you write the interval notation, we will write our interval notation from small number, which is from negative infinity. My answers are coming from negative infinity, comma, means the word 2, from negative infinity all the way to 8, and using a bracket on 8 to tell the reader that I do include 8 as part of my answer. All right. So when reading, so in your first discussion question, when reading number lines, why do we read from left to right? It's because we read from small number to the large number when we read the number line. All right. So with that out of the way, let's take a look at this, some of these definitions. Okay. Identify whether a relation is a function or not a function. A relation, this word, the relation is referring to a set of ordered pairs, just like what you see down here. Oh, I meant to change that to a comma. It's a set of ordered pairs. Okay. So the set consists of first components of each order pair is called domain. So first component are the x values. The first component are the x values, right? Which is called the domain. And the set consists of second component of each order pair. Second component are the y values. Those are called the range. All right. So what is a relation? It's simply a set of order pairs. So here I got 1, 2, 3, 4, 5 order pairs. So a function, okay, by definition, a function is a correspondence between the domain and the range such that every element in the domain corresponds to exactly one element in the range. So there are a couple words in here that we don't quite know. What exactly is a domain? What exactly is a range, right? Domain, okay, like up here, the first element, the first component in each order pair is called domain. So that means domain is actually labeled as x values. We also call the x values the input value or independent variable. In terms of looking at a graph, domain is referring to how wide the graph is from left to the right. Okay, how wide it is from left to the right. Range, second component is of each order pair is called the range. So range, well, is also labeled as the y value. Also, the y value is what we so-called the output value in algebra. The variable y is a dependent variable. In terms of a graph, okay, range is referring to how tall the graph is from bottom to the top. Okay, how tall it is, what's the height of it. So if I graph y equal to x is the most basic graph, right? So if I go to my calculator and go to y equal and simply typing x, y equal to x and press graph. Oh, sorry, let me fix my window. So to fix a window, go to zoom, choose number 6, zoom standard. Every graph should start with a zoom standard. This is standard window, which is from -10 to +10 on both x and y direction. So this is a typical y equal to x, a graph for this linear equation. It does pass through the center. Okay, so if we reread this definition of a function, okay, function is a correspondence between domain. Domain is basically x value, right? So a function is a correspondence between all the x value and the y values, such that every element in the domain, every x value corresponds to exactly one y value. Every x can only correspond to one y. So here's a scenario, okay? Every x corresponds to one y. So if I have an x value 2 and an x value 3, gotta correspond to one y value, okay? But the tricky part is what it doesn't say is what happens when it corresponds to exactly the same y value. Well, that's okay as long as different x values correspond to a y value. As long as different x value correspond to a y value, I'm okay. What is not allowed is the same x value, like 3 and 4, correspond to, excuse me, the same x value correspond to different y value. That is not allowed. Cannot have the same x value. For a relation to be a function, okay, every x value can only correspond to one y value. So every x value is not quite exactly how we're supposed to say it. It's every different x value co correspond to exactly one y value. Okay, just like the straight line. Straight line technically is considered as a function because all the x values on here on this blue line I drew correspond to one y value. Okay, so the point is, for a relation to be a function, the relation just cannot have the same x value. If it's the same x value, it's not a function. So what did we drew before? What did we draw before have this, that has the same, that actually consists of the same x value? What did we draw before that has the same x value? Let's go back to topic number 8. This is something we already did. Vertical lines. On the vertical line, all the x value is equal to a number, right? All the x values are the same. So this example we did back in topic 8, x equal to 2, right? So that means on this vertical line, all the x values are the same. So to be a function, you cannot have the same x value, okay? Because every different x value correspond to one y value, but the vertical line, all the x values are the same. Okay, that's the reason why vertical line is not a function. As a matter of fact, we can actually use vertical line to test out whether a graph is considered as a function or not a function in a different topic. Okay, so just keep in mind right now, just make sure you understand that every different x value can only correspond to one y value. Okay, just cannot have the same x value, otherwise it's not a function. If we go back and take a look at the idea of a domain and a range, okay, domain, how wide the graph is. So remember, this is an x and y axis, so we got 2 dimension going on here. Okay, left to the right. This arrow is keep on going right. This arrow is keep on going left. Remember, there are infinite number of points on this blue line. Line never ends, so therefore there are infinite number of points. Out of all the points on here, just looking at the x values alone, okay? Keep going left means your x value keep on getting smaller. Going to the right, that means your x value are keep on getting bigger. So your domain, right? Your x values got to be coming from negative infinity, small to large, all the way to positive infinity. Okay, so that tells you how wide the graph is. The graph is coming from negative infinity to all the way to the positive infinity. And when we say domain, we are thinking about how wide the graph is, and we are also thinking about all the x values on this line. Range, how tall the graph is. This arrow is pointing left, but it's also pointing down at the same time. This arrow is pointing right and also pointing up at the same time, right? So when we talk about the height of the graph, how tall the graph is, we are thinking about all the y value, which is the range. So how negative does my y value go down to? Gotta be coming from left to the right or down to up coming from negative infinity all the way up to positive infinity. So that's my domain and range for a linear equation. Okay, so this is a big change. Okay, this word function is a big change. All right, let's try this example. Okay, for relation below, okay, same exact points from earlier. Determine the domain. The domain is referring to as the x value using set notation. So all I'm going to do is write down all the x values, right? 2, 4, -3, -2, and there's another 4. I'm not going to repeat the same number I said number again. So right here, I got 4 here, 4 here. For a relation to be a function, I cannot have the same x value. So right now, this relation is not a function. Range is looking at all the y values, right? All the y values. So I'm just going to write in the set notation. -3, 2, 3, -1, -4. Okay, so let's plot this. Okay, 2 comma -3. To the right 2, down 3. Right here. 4, 2. To the right 4, up 2. -3, 3. -3, 1, 2, 3, up 3. -2, -1, -2, down 1. So the relation here, 4, -4. To the right 4, down 4. This relation is simply consists of 5 points. I'm not connecting with a line. It's just 5 points on the graph. Together it's called a relation. And this relation is not a function because I do have the same x value. See the 2 4s right here, top and bottom. These 2 points, top and bottom, actually tells you that I have the same x value. So it's not a function. All right. So here is a big jump. Different types of functions. Okay, the function notation y equals or y is equals, that means is. Y is a function of x. So we no longer, so back in the previous topic, for the linear equation, we solve for y equal, right? To write it as a slope intercept form, y equal to mx plus b form. Okay, so to graph, we always solve for y. Okay, but now we are changing that later y as a function of x. Okay, so whenever I'm using the word function, this is a big conceptual jump. Whenever I use the word function, it's now referring to 2 things, because before I have to use 2 different words. I have to say the word equation. I have to say the word graph, right? Equation of the line, But right now, those 2 things can be in one word called the word function. So when the word function is being used, it's referring to as the equation part, and is also referring to as the graph part. It means both. Okay, it's referring to both. So y is now a function of x. Okay, so we don't say y equal anymore. We don't say linear. We don't use the word linear equation, quadratic equation, because when we use the word equation, we only look at them as equation. But when we use the wording equation of the line, means the line is the equation, the equation is the line. They are the same thing, just in 2 different forms. Okay, so instead of constantly changing the word, instead of keep on using the word equation and the word graph, now we're just going to call them function. Okay, so your linear function. Okay, so we don't say y equal, we say f of x equal function of x. Your standard form for a linear function is called f of x equal to mx plus b, which is that same thing as that slope-intercept form. Okay, so a basic graph, like I showed you earlier, for a linear function, not a linear graph, okay, is basically a straight line. And earlier I wrote down the domain and the range for you. Okay, domain, keep on going right, coming from very, very left. So the domain gotta be negative infinity to positive infinity. Okay, your range, this arrow keep on pointing down, the y value keep on getting negative. The other arrow, the y value keep on getting more positive. So the range is negative infinity to positive infinity. So all linear function has exactly the same domain and range. That does not change. So in a previous topic, we reviewed solving quadratic equation. Okay, that equation has a graph. Now, put the two together, we just call them quadratic function. Quadratic function has a standard form of f of x equal to ax squared plus bx plus c. This is a standard form for a quadratic function. I know it's a quadratic function because I'm actually, my function has x squared to it. Linear function is x to the first power. Okay, so by looking at these forms, these forms also identify what type of function we are dealing with, or what type of graph we are dealing with. Okay, so let's go to our calculator. So to graph quadratic function, go to y equal, type in letter x, rate, caret key, raising to the second power. Press graph. A quadratic equation is a shape of a U. This U can open down or it can open up. Open up or open down, either way. So I'm gonna indicate one specific point right now is at the very bottom of the U is sitting at the origin. Okay. So if we look at the domain of my quadratic function, this arrow keep on point up, at the same time also keep on pointing to the right. This arrow pointing up, also pointing left. So your x values on this graph coming from negative infinity, coming from very, very left, right? Keep on going to the right. The range will be different. Okay, the range will be different for a quadratic function. For every different quadratic function, the range will change. It all depends on where the bottom of the U is located. For a quadratic function like this one, currently, my very bottom is sitting at the origin, right? So the range is the y value, both arrow pointing up. So when we do the range, right, it gotta be from down to up. So the y value starts at 0. That's the lowest point, right? That's a very bottom y value. Keep on going up to positive infinity. So for this particular example, okay, to infinity sign always use parentheses. Okay, 0, this y value 0 is part of this line. So I gotta use a bracket. So my range starts from 0. The smallest y value is starting at 0, keep on going to infinity. But like I said, the range is only for this particular example. Okay, different quadratic function will have different range. So I'm only gonna write down what is set to be true always. If I have a parabola open downward, okay, the graph of a quadratic function is called a parabola. I do use that word. I need to write it down. Parabola. So if my parabola point downward, this arrow pointing down, but also pointing to the right, this arrow pointing down and also pointing left. So my domain is still negative infinity to positive infinity. My x values are still coming from negative infinity to positive infinity. That doesn't change. All right, rational function. The rational function has two basic version, okay? So this 1 over x. So how do I know this is called a rational function? The word rational, we talked about rational expression before, right? Rational expression, basically it's a fraction expression. So we know this is called a rational function because this is written in form of a fraction. So if I go to y equal and type in 1 divided by x, okay, this is what a typical rational function will look like. This is a little bit small right here. It does look like this line kind of stops right here, but it doesn't. Let me zoom in the window a little bit. So to change my window, I go to window. I'm gonna shrink this window. I'm gonna squeeze them left to right, top and bottom. So I'm gonna make the x minimum to -5, x maximum 5. I'm gonna squeeze it inward. So if I squeeze it in, then the graph will pop. See, this line keep on going. Doesn't it just it's darker right here on this darker right here is because the line is getting so close to the x-axis. It look like a double line. Okay, that's why it appeared to be a little bit darker. It's very, very close to the x-axis. Okay. Let's go back to look at this rational function. Topic number 6, the very first thing when we talk about rational functions is this thing called the restriction on the variable, right? Set the denominator not equal to 0 and solve for x. Okay, it will tell me what my x cannot be because I do not want my denominator equal to 0 because if it is, the whole thing becomes undefined. Okay, that was called the restriction on the variable, but in reality, it's called the restriction on the domain. Restriction on the domain, what x cannot be. This denominator cannot equal to 0, right? So that means my x values, all the x value on this graph, x just cannot equal to 0. So one restriction on the domain, just like if you hold up 2 fingers, there's one space between your 2 fingers, right? One restriction, your graph is split into 2 parts, right? That's why when you hold up 2 fingers, there's one space. That space is now the restriction. So that's why your graph is split into 2 parts. If you got 2 restrictions on the domain. So if you hold up 3 fingers, you see 2 spaces. So 2 restriction, 2 spaces, your graph is divided into 3 parts. So your domain, this side, this arrow pointing to the left, right? So that means your x value is coming from -infinity all the way approaching what x cannot be. X cannot equal to 0. So I use parentheses. So that's the left side of the graph. Union means the word or it means the word or my graph can be from 0, right? 0 is almost like my reference number I'm using. Keep on going to the right. There you go. One restriction, your graph in 2 parts. So when we read this domain, we actually understood your x values are coming from -infinity all the way to 0, but not including 0 because that's your restriction. Union connects the 2 parts, right? Or union is the word or my domain can be from 0 all the way to infinity, but 0 is not included. Okay, we don't talk much about range for rational functions. All right, let's take a look. So as I'm drawing these, please start memorizing what these pictures start look like, okay? Because this is the topic. These pictures are what I'm gonna referring back to constantly, in the next several topic. All right, 1 over x squared. So 1 divided by, this time I'm gonna use parentheses for that x squared just in case. Okay, 1 over x squared look like this. Okay, so this window is still still changed. It's still the one I fixed earlier. If I go by the standard window, it look like this. So again, the darker part does not end there. It keep on going. It's just hovering right above the x-axis, okay? The graph is hovering right above the x-axis. Very close. But it doesn't touch it because x cannot equal to 0. Okay, it doesn't quite touch the x-axis. So my domain, this arrow keep on coming from the very left, your x value coming from very left, your x value keep on going to the right, okay? So if I set my denominator x squared not equal to 0, take a square root on both sides, right? When we take a square root on both sides, my answer is always positive and negative. Positive, negative, 0 is still 0. My x cannot equal to 0. So again, one restriction on the domain, my graph is 2 pieces. My domain coming from negative infinity all the way towards 0, union from 0. The other part of the graph is from 0 all the way to infinity. Okay, use parenthesis on the 0 because that's my restrictions. All right, absolute value function. This is one thing I did not review yet, is how to solve absolute value equation, which I will do that in the other topic. But for right now, to grab absolute value function, let's go to y equal. Okay, for absolute value symbol, math, number 1, ABS, absolute value of x. Absolute value function give you a shape of a V. Absolute value function is very much like a quadratic function, the parabola. This V behave very similarly as the parabola. Okay, this arrow pointing up, but also pointing left. This arrow pointing up, also pointing right. So my domain got to be from negative infinity. All the x value come from negative infinity, real small, all the way to the right, to positive infinity. Okay. Cubic function, x to the third power. This is considered as a polynomial function, which we'll spend a lot of time talking about it. So as you can begin to see, many topics that we review so far in this class is a type of graph, is the type of function. So x to the third is called a cubic function, or generally it's a type of polynomial function. So let's see what it look like. X raising to the third power. Letter x is right here, right? Graph. It look like this. It does pass through the origin this time. Okay. All right. I know this arrow is pointing down, but it's also pointing left. This arrow pointing up, also pointing to the right. So a cubic function, your domain is always from negative infinity, your x value coming from very negative all the way to the right. So a lot of student says, okay, how can you tell? Well, if you go to the table, right? If you go to the table, press second graph, keep going up, your x value is more negative. So as your x value getting more negative, your y value is also getting more negative because this arrow pointing downward. Downward means y is negative. So how far can I keep going, right? It's basically negative infinity, right? I can keep going. I can keep going left, or in this case, in the calculator, keep on going up, or I can be more positive, right? Either way. Ooh, my calculator froze. I knew it. But it's all right. I will show you. I will grab these by hand. All right, a square root function, okay? Radical function I have a square root and a cube root here. Okay, for a specifically for a square root function, okay, it will look like this, starting at the origin. So again, it can change, okay? This starting point can change. This is all it does, just like that. So for this particular example, right? I'm starting at the origin. My domain, my x value starts at 0. Origin is where the x value and the y values are 0, 0. So my domain starts at 0 using bracket because it's part of the point, all the way to the right. All the way go to positive infinity. But again, this square root function can change. Okay, just for this example, is from 0 to infinity. All right, your range, your y value, right, starting at 0. Okay, keep on. This arrow is pointing right, but it's also pointing up at the same time. So that will be from 0 to infinity. All right, cube root function is part of the radical function, right? The word radical means roots. This one will look something like this. So again, it looks like it's flat, but it's not, okay? It appears to be flat, but it's really not flat. This pointing left, this pointing right. But the y value is what's interesting. This does not appear to be flat. The y value just changes so small. The one y value to the next y value, the difference between one y value to the next y value are so tiny, it make it appear to be a flat. But this arrow is pointing left and pointing down at the same time. Okay, if my calculator were, I could have show you the y value. Each y value is so different. So the differences between them is so tiny, you can't even, the graph just, the pixel on the graph make it look like it's flat. Then this side keep on going up. So the range is actually from negative infinity to positive infinity. The domain coming from very left all the way, coming from very left, keep on going to the right, negative infinity to positive infinity. That will always be the case. All right, so please remember some of these pictures, or begin to remember some of these pictures. I will constantly referring back to this topic and showing you. So how do I know this is called a square root function? Well, because there's a square root. How do I know this is a cube root function? By looking at the equation part. Well, because it's a cube root. How do I know this is an absolute value function? Because the absolute value symbol there, right? A to the third power is a cubic function. Okay, you're just looking at key parts of this. The key part. This is how you identify what type of function it is. Okay, how do you know this is rational? Because the fraction. And how do you know this is linear? Because it's to the first power. This is quadratic to the second power. All right, what does synonym notation is used to describe? So just copy what I wrote on the lecture handout on the first page. A function is a correspondence between a domain and a range, such that every different x domain corresponds to exactly one range, one y value. All right, this is the same example as the one I just did. Okay, use a set notation for your domain. Just write down the x value. Using set notation, okay? Range, just write down all the y value using, if it's repeat, you don't have to write twice. No, use semicolon, Okay, so if the x repeated, then it's not a function. All right, so thank you so much for watching this lecture video on functions and graph. Okay, so we define what a function is, domain and range, and we looked at all the basic types of a function we're going to introduce in this course. Thank you so much for watching.